Today, solar energy is everywhere. Vast solar farms stretch across deserts, rooftops glitter with shining panels, and even highways and parking lots are coated with this futuristic glass. More than 1 billion panels now capture sunlight every day, converting the rays of the sun into pure electricity. They are a cornerstone of humanity's fight against climate change. But there is a question that is rarely asked. What happens when these panels die? Solar panels are not immortal. Their average lifespan is between 25 and 30 years. After that, their efficiency drops. The first wave of solar installations built decades ago is already reaching the end of its life. By the year 2050, experts predict that humanity could be drowning in over 70 million tons of solar waste. And here lies the paradox. A technology created to save the planet could one day become its burden. The challenge comes from the design of the panel itself. A solar panel is not just a sheet of glass. It is a carefully engineered sandwich of materials. Tempered glass on the outside, aluminum frames for structure, plastic polymers for insulation, silver wiring to carry electrons, and at its core, fragile wafers of silicon, the very heart that captures sunlight. To recycle it means to undo this sandwich, to separate each valuable layer without destroying it. That is easier said than done. This is where the supergiant solar panel recycling plant comes in. Imagine a facility so large that it processes thousands of panels every day, turning mountains of solar waste into usable raw materials once again. Here, the life cycle of solar technology is closed, and the dream of a circular green economy begins to take shape. The journey starts when trucks loaded with old and broken panels arrive at the facility. Some are cracked from hailstorms, some are yellowed from decades of exposure, others are simply outdated and replaced by newer, more efficient models. Workers and robotic arms unload the panels and send them onto conveyor belts. Each panel may look like trash, but inside are materials that are far too valuable to throw away. Aluminum, silver, copper, high-purity silicon. The first step is shredding. At this stage, the solar panels are fed into enormous machines with rotating steel jaws. In seconds, what was once a gleaming panel is reduced to fragments. Glass, plastic, and silicon shatter into small pieces while metals are torn free. To an outsider, it looks like destruction, but in reality, it is the first step toward rebirth. Breaking the panel down is the only way to separate its components. After shredding, the fragments move onto the sorting line. This is where chaos is transformed into order. The first separation is magnetic. Large magnets attract steel parts, screws, nails, mounting hardware, pulling them away from the stream. What remains continues forward, where powerful eddy current separators push aluminum aside. Aluminum frames, once holding the panels together, are now collected to be melted down and reused in new construction, or even new solar panels. The next step focuses on the glass. Solar panels are about 70 to 80% glass by weight. Shredded glass particles are filtered and cleaned until they can be reused. Some of this glass ends up in new solar panels, while others are recycled into bottles, insulation, or building materials. Nothing is wasted, but the most important part is still hidden within the mix: the silicon cells. These delicate blue wafers are the true engines of the panel, and recovering them is both the most difficult and the most valuable task. To reach them, specialized processes are used. One technique involves heating the shredded material to soften and peel away the thin plastic encapsulant layers that cling tightly to the silicon. Once freed, the wafers can be purified, melted, and transformed into new cells for new panels. This recovery of silicon is groundbreaking. Silicon is one of the most abundant elements on Earth, but producing it in the ultra-pure form needed for solar cells is energy-intensive and costly. Recycling old cells into new ones saves enormous amounts of energy and resources. In some advanced plants, over 90% of the silicon is successfully recovered. Then comes the silver. Each solar panel contains thin lines of silver paste that collect electrons from the silicon. Silver is rare and expensive, making up nearly half of the panel's total material value. Through chemical baths and electrolytic processes, the silver is stripped out, purified, and collected. These recovered grams of silver, multiplied by millions of panels, create a supply worth billions of dollars. Step by step, the supergiant recycling plant transforms waste into treasure. Broken panels become glass cullets, aluminum ingots, silicon wafers, silver bars. From destruction comes creation, and from trash comes power once again. The scale of the operation is breathtaking. Conveyor belts stretch for hundreds of meters. Robotic arms sort materials with speed and precision. Entire mountains of waste shrink as truckloads of clean raw materials roll out the other side. What once looked like a problem, the end of a solar panel's life, has become an opportunity. But the story is not just about machines. It is about the future of energy itself. Solar power has grown faster than anyone predicted. In the United States alone, enough solar energy is installed every year to power millions of homes. Globally, we are adding hundreds of gigawatts annually. And with every installation comes the responsibility of dealing with the panels when their time is up. If we do not recycle them, they could end up in landfills, leaking toxic substances, and wasting valuable resources. But if we do recycle them, we close the loop, creating a sustainable cycle where old panels give birth to new ones, where today's waste becomes tomorrow's clean energy. This is why solar panel recycling is more than an industrial process. It is a vision of the future. Imagine a world where every solar panel is reborn, where no resource is wasted, where the sunlight of yesterday fuels the sunlight of tomorrow. At the heart of this vision are the silicon cells, tiny, fragile, but infinitely powerful. They remind us that technology is not just about invention, it is about reinvention, the ability to give life again and again. If you believe in a future where technology and nature work hand in hand, then join us on this journey. So hit that subscribe button, and let's keep building a brighter, cleaner tomorrow, one story at a time. Used cooking oil, the greasy, messy, brown liquid left after frying French fries or chicken wings, is one of the least glamorous waste products in the world. Yet, in facilities across America and beyond, it is being transformed in a way that is nothing short of astonishing. This is the story of the supergiant oil recycling process. A behind-the-scenes journey into how millions of gallons of waste oil are collected, purified, and reborn as something powerful. Before we dive into today's fascinating story, I've got a quick favor to ask. If you love discovering how everyday things get transformed in ways that blow your mind, make sure to hit that subscribe button and turn on the notification bell. As the trucks roll through the facility gates, they line up at the receiving station. Giant hoses are attached and the contents of the trucks are pumped out. The numbers are staggering. One truck can carry up to 7,000 gallons, and in a single day, a plant may receive dozens of them. Within hours, hundreds of thousands of gallons of used oil are safely stored in massive tanks, each the size of a small building. These tanks are the temporary resting place before the oil begins its transformation. Before anything else, the oil must be screened. At this stage, it is full of visible debris, bits of breading, fries that slipped through the fryer basket, and other less cloudy, and already much cleaner than before. By the end of this step, the oil has been stripped of most of its solid impurities, but the oil still holds a hidden problem. Water. Used cooking oil often contains 5 to 10% water, either from the food that was fried in it or from condensation. Water is dangerous in the recycling process. It reduces efficiency and can damage machinery if left inside. To solve this, the oil is gently heated in massive dehydration tanks. As the temperature rises, water separates and either settles at the bottom or evaporates into steam. What's left is a golden liquid that looks surprisingly pure compared to the black sludge that first arrived at the plant. At this point, you can almost imagine it being usable. But to turn it into fuel, one more giant leap is needed. Now we reach the heart of the process, the transformation of oil into biodiesel. This step is called transesterification, a technical word that hides a simple idea: rearranging molecules so they can burn cleanly as fuel. The dehydrated oil is mixed with alcohol, often methanol, and a chemical catalyst such as sodium hydroxide. The mixture is pumped into giant reactors, some as large as swimming pools, where it is stirred and heated under controlled conditions. During this reaction, the triglycerides in the oil are broken down into methyl esters, the chemical name for biodiesel, and glycerin. After several hours, the reactor produces two distinct products. On top, the lighter biodiesel. At the bottom, the heavier glycerin. The two layers are separated, and each goes on its own journey. The glycerin can be refined into ingredients for soap, cosmetics, or pharmaceuticals. The biodiesel, however, is the star of the show. Even after the reaction, biodiesel isn't ready to be pumped into engines just yet. It must be washed and polished. First, it passes through water washes or dry washing columns that remove any remaining catalyst, methanol, or traces of soap formed during the reaction. Then it is filtered one more time through fine industrial filters. What emerges at the end is a golden, clear liquid, clean biodiesel that looks almost like honey. Laboratory testing is conducted on samples to ensure it meets strict fuel standards. Only when it passes every quality test does it move forward to the final stage. Now the biodiesel is ready for use. It flows into gigantic storage tanks, each capable of holding millions of gallons. From here, pipelines or tanker trucks distribute it to fuel stations, transportation companies, or even directly to city bus fleets. This is the point where the circle closes. Waste oil that once dirtied kitchens and clogged drains is now a clean, renewable fuel, powering trucks, buses, and sometimes even airplanes. What began as a problem has become a solution. To truly understand how big this process is, let's look at some numbers. In the United States alone, billions of gallons of used cooking oil are generated every year. A single supergiant recycling plant can process tens of millions of gallons annually. 1 gallon of biodiesel replaces 1 gallon of petroleum diesel. That means millions of gallons of fossil fuel are disposed. No more pollution from dumping oil into rivers or landfills. Instead, a closed loop: food to oil, oil to energy, energy to life. And that's the incredible journey of used cooking oil. rescued from restaurants, purified in giant facilities, and reborn into clean fuel and countless new products. Pretty amazing, right? If you enjoyed this deep dive and you want to see more stories about how the things we throw away get a second life, go ahead and hit subscribe right now. Don't forget to tap the notification bell so you'll be the first to know when our next video drops. Thanks so much for watching. Take care of yourself, and I'll see you in the next one. We use them every day to pack our lunches, store leftovers, or deliver takeout. Plastic food containers are everywhere, but what if we told you some of them were made from yesterday's trash? That soda bottle you threw away last month, it might be holding salad today. In this episode, we go behind the scenes to uncover how discarded plastic, once destined for landfills or oceans, is collected, purified, melted down, and reshaped into safe, durable containers fit for your fridge and your microwave. From curbside bins to cutting-edge machines, and from dirty waste to food-grade clean, it's a journey of transformation that combines recycling, chemistry, and precision engineering. This is more than just plastic, it's a second chance. Welcome to How It's Made, recycled plastic food containers. The journey of a recycled plastic food container starts long before it reaches the factory. It begins at the curbside. Across neighborhoods, cities, and commercial zones, used plastic bottles, food packaging, and containers are dropped into recycling bins. These items are then transported to regional materials recovery facilities, where the transformation begins. Upon arrival, the plastic waste is unloaded in massive piles and pushed onto conveyor belts. The first round of sorting is mechanical. Large spinning drums separate light materials like film plastics from heavier objects. Magnets pull out any stray metals. Then comes the key step, optical sorting. High-speed infrared scanners detect the type of plastic based on how each piece reflects light. Once identified, powerful air jets separate PE, polyethylene terephthalate, from PP, polypropylene, and so on. These are the two most commonly recycled plastics used for food containers. Manual workers follow, picking out non-recyclables, dirty items, or anything that could contaminate the batch, like greasy pizza boxes or foil. The selected plastic is then grouped by polymer type, color, and grade, and moved into separate holding bays. Any container that once held chemicals, paint, or hazardous material is discarded, because only the cleanest feedstock can become food safe again. Once sorted, the plastic heads for a thorough washing and shredding process. But even at this early stage, the path from trash to table has already begun. Once the plastic has been sorted by type and quality, it moves into the next phase, transformation. Large conveyor belts carry the selected plastic into a granulator, an industrial shredder with sharp rotating blades that pulverize bottles, trays, and containers into small flakes, each about the size of a fingernail. This process dramatically increases surface area, making the next steps more efficient. But before these flakes can be remade into food-grade containers, they must be spotlessly clean. Shredded plastic enters a friction washer, where high-speed paddles agitate the flakes in a mixture of hot water and biodegradable detergent. This removes any residual food, labels, glue, and surface oils. Now that the plastic flakes are clean, dry, and sorted, it's time to turn them into something new. Plastic pellets, the building blocks of nearly every plastic product made today. The flakes are fed into a twin-screw extruder, a long cylindrical machine that both heats and mixes the material. Inside, giant rotating screws push the flakes forward while raising the temperature to over 250 degrees 482 degrees Fahrenheit, hot enough to melt plastic, but not to degrade it. As the plastic becomes molten, it's forced through fine mesh filter screens that remove any remaining microcontaminants, like tiny bits of paper, glue, or metal.